All right, this is the eighth and final section in Chapter 1, and it deals with representing functions as graphs. All right, so in this first example, it says graph the function of y equals 2x minus 1 with the domain 1, 2, 3, 4, and 5. So what I'm going to do first here is take the domain or the inputs and put them all here in a table. So we can organize. So we got 1, 2, 3, 4, 5. So the first step is take this information, organize it in a table. Once we get it organized in a table, then we're going to graph it. So when x is 1, if we plug it in here, we're going to have 2 times 1 minus 1. Well, 2 times 1 is 2. 2 minus 1 is 1. So when we have an input of 1, the output is 1. When x is 2, we have 2 times 2 minus 1. Well, 2 times 2 is 4. 4 minus 1 is 3. If we put a 3 in for x, we have 2 times 3 minus 1. 2 times 3 is 6. 6 minus 1 is 5. And we could keep continuing doing this, but I'm also noticing a pattern over here. As x increases by 1, look what's happening to y. It increases by 2. So this becomes 1, 3, 5. So we would predict that 7 would go there and 9 would go there. So 2 times, just to check this, 2 times 4 is 8. 8 minus 1 is 7. And 2 times 5, 2 times 5 is 10. 10 minus 1 is 9. So yeah, that was the pattern. So once we get this information organized in a table, we could take those values and graph it on a coordinate plane. So there's the x and there's the y. When x, we always start at the origin here. When x is 1, so we move over 1, y is 1, move up 1, put a point there. The next one, if we start at the origin, we're going to go over 2, up 3. The next point, we'll start at the origin, we're going to go over 3, up 5, over 3, up 5. Start at the origin, over 4, up 7. And starting at the origin, over 5, up 9. Alright, the second example here. The table shows the profit P in thousands of dollars at a small toy store each year from 2000 to 2004 as a function of the time in years since 2000. Graph the function. So we've got a table here. We want to create a graph to represent this information. Okay. Down here, I'm going to put this as years since 2000. And then for this y-axis, this is going to represent the profit in thousands of dollars. Okay, so this is going to be our P. This is our profit over here, so this would be our P-axis. This is going to be the years, the times. This would be our T-axis. I'm going to put this at 0. I'm going to make some intervals here and decide what we want to use here. Okay. Well, it goes from 2000 to 2004, so I'm going to use my increments in years in going up by ones. But I don't have to label every single interval. I'm going to go every other. This is 0. We know that's 1. I'm going to label this one 2. We know this is 3. I'm going to label this one 4. No, that's 5. I'm going to label this one 6. No, that's 7. I'm going to label this one 8. Okay. The profit if we look at our table, and again, this is in thousands of dollars, so this is, 19,000 and a half, 20,000, and so on. So there's nothing between 0 and 19,000. Whenever we have a big jump like that, we can put in what we call a break. That way it just cuts all that out and we can go right to, say, 19,000. Okay? And I'm going to go up by thousands here because, it's 19,000, 19,000, 20,000, 22, 21, and 21. So let me just get these in here. And again, I'm not going to put in every single one. We can go every other. If we know this is 1, this is 19, this would be 20, this would be 21, 22, 23. So I'm going every other one because I don't want to. If I were to write every single interval in here, it's going to kind of crowd the graph and maybe make it difficult to read. So let's go ahead and graph some of these things here. So at 0 years, we're at about 19, little about halfway between 19 and 20. So we'll put a point there. For the 1 year since from 2000, it's 20.3 thousand. So that's going over here to 1 year, going up. It's a little bit over 20. 2 years, it's over 22, but closer to 23. So I'll put a point in there. Then for 3, it's 21, just above 21. So I'm going to kind of estimate that it's in here. And then for 4, it is 21, in between 21 and 22, but closer to 22,000. So I'm going to put that in there. So we've taken this information and we've graphed the function. Alright, so this third example here, write a rule for the function represented by the graph, identify the domain and the range of the function. Alright, so here's the graph. I'm just going to go ahead over here and look at these points and just fill in the chart. So as I'm looking over here, this over here should be the x-axis. So here's the x-axis going across here. Here's the y-axis vertically going up and down. Well, the value of x, if we go over here, is 1. When x is 1, y is 2. So we have an input of 1, an output of 2. When x is 2, y is 3. So we got 2, 3 here. When x is 3, y is 4. When x is 4, y is 5. And when x is 5, y is 6. Okay, so got that filled in, and then we're going to look at what happens to the input each time. So writing a rule and look at what happens here. So if you look at the input, well, from here to there is an increase of 1. If we look at this input from 2 to 3, that's an increase of 1. This input of 3 goes to 4, that's an increase of 1. This input of 4 to 5, that's an increase of 1. And again, this last one here from 5 to 6 is an increase of 1. So we're always taking the input, which is x, and we're always increasing it by 1. So there's our rule. Okay. It wants us to also identify the domain and the range. So the domain is just to list all the x values or the inputs. So that would be 1, 2, 3, 4, 5. So there's the domain. And the range would just be the set of all the outputs or the y values. So that would be 2, 3, 4, 5, and 6.